camera. I have to talk to the big old camera. Talk to the big old camera. So Vivian Ward. Hello, welcome back. Hey, hi, hey. So what we're gonna do is we're gonna do a Bluetooth update with tape to kind of give you a good layout. We'll talk about the next tube structures that are gonna be going on probably while you're watching this, where things are gonna go, kind of finalizing the chassis, what that's gonna look like, just the rest of the structure, some of the packaging, and then dive a little bit into the next steps of shock mounts. But really what I'd like to cover is how we're gonna fasten this cab to the chassis in a way where it's not gonna need to be welded on. And then also what we wanna do for paneling in here. We're gonna do this unorthodox. It is not, and I guess it's not I guess it's not unorthodox. It's just not your typical sealed cab. Silicone bronze, the shit out of it, everything, you know, like it doesn't need to be like that. We'll have more of this be a removable panel situation, a lot more aluminum, things like that. So right off the bat, like one of the most uncomfortable things for me, like showing the cage and where I feel vulnerable looking at it. So last episode we talked about building this front structure out and kind of landing where we could. And that being said, and then also keeping an inch from the outside of the tube structure to the inside of the cab on each side. Something I'd like to cover is just how we ran this A-pillar and kind of what's going to go on from here. We really had a structure we wanted to tie into, and we also wanted to not fall short of, you know, having like big gaps and stuff and obstructions in the vision, you know, and your tunnel of vision from driver and passenger. This thing, if we wanted to just run it, like we're very tight on the top up here, but if we wanted to run down into the structure, it's going to create a cavity in here that's substantial in a matter of 2 to 3 inches, where we'd really just be shitting the bed. So there's a bend cracked in here. And what's going to happen here is we'll have a big radius gusset, same 2-inch, everything's going to be standardized 2-inch, and then we'll have a secondary A-pillar. So I can kind of get the gist of this. We're gonna crack a bend in that secondary A-pillar, but I won't be able to crack that bend unless I do some shit, which I actually can. Hold on. I think it's important just to kind of show the thought process here of what we want to do and how we're gonna do it, and not just, and I guess we've done this all along, but showing the process and not just the final result, or look, this has this and we did this and this and that. And like, I'd like to show what goes into this a little more, and this, you know, update is going to be covering more of that and speaking through the imagination. I mean, think of it like reading a book, right? So back when I was growing up, people read books and books just had text and stuff. No, I'm not doing that. This is a way to show you what we're going to do before we do it, and so you can kind of conceptualize it yourself and see what I'm communicating, and then see it actually be done. I just have this here to kind of register as a bend line. It's very similar to what we have here. It's a little higher, but what this is going to let me do is, at least when I put my tape in here, it's going to draw the tape outwards towards the profile we want and then back down instead of floating. So that secondary A-pillar, it's going to do something like that. Now that's going to be a 120 wall tube, because it's a big kind of a very incremental structural piece. And what we'll do is We'll tie in another to our junction up front here. But this will be your primary, be your secondary, and then we're going to have kind of a custom plate structure tying in here. We have a dash coming that we're going to use for this thing, just to off the shelfer that we're going to tie in, but you'll see that this whole program here will be like a cool plate structure just to kind of mix it up and bank on that bend and these two structures. So that's going to be your outlier there. Your B-pillar support is going to come in clutch right through here. So what that does is it gives you kind of some ingress egress as far as getting through and back behind here. It gives you a lot of head clearance, so you don't just have a big typical guy going through here. And also ties your structure in, because this is your main support. This is your main impact support. So the last thing you want to do when you're building these things is your door bar, just to be able to work around easier, not have to crawl over this shit. But this is kind of going to solidify like your section. Don't worry about the straight edge, that's there to help us. But that's, instead of just being one A-pillar structure, you're going to get almost an entire doubler of a structure there with the, the primary, then your gusset, and then your big plate structure, and then your two downs into the pedestal down there. So obviously if you start following this thing, you can see everything's kind of got its home. And then we go back to that wall we talked about last episode. And I'm going to shoot just this side and see where it's going to be, but I don't know exactly where it'll be until we really put some real thought into it. Your shocks don't need more than what they have there, so you're really just identifying the rest of your structure in the chassis. Flying W. That kind of ties that in. Now whether this moves in or out more, it probably will. We just got to kind of cycle that thing. And you can bank on that being the same on this side. I don't think we need to do both. Another little item too I'd like to add is just putting a core into here to finish this junction off. And I think just adding this guy, do a 065 wall thickness tube right there, and that'll kind of solidify that whole thing. You also, and I don't think it needs to be there, but something to think about too, like we're gonna have our shock mounts, will roughly be in this location. So think about that. I don't know if we want a tube here and just kind of close this off as our cavity for this stuff. We need to also pay respect to where the two rear seats are gonna go. It's kind of your typical intrusion tube setup. Obviously, like you'll see trucks that have their motor set pretty far back. Most of the time, they end up with these tubes like really inset into the cab. There's ways around that, like on the Exotic, we kind of cheated to get around that program where they're not so far back and they have more angle to them. A lot of that is just out of necessity of getting the engine out. If you had this angled more towards the front of the car, then there's going to be more packaging constraints of getting this thing out. So we use AeroTube on these as like a signature look and spec. The way to think about that is what the intrusion tubes do, besides like the obvious intrusion, like a barrier, they are a support tube. They're just a lateral support. They don't really do much twisting and impact. They just do constant support for this. So in case of these corners or whatever having a gnarly crash or impact, they're just up vertical supports or diagonal supports. Just like if you stood on an empty can, like a soda can, and you balanced on it, it would completely hold up everything, because all it's doing is being a lateral support, and then if you flick it, it's getting a side load and it's failing. And it's not saying that these would fail, but it's just a reference as to like what lateral support means and what the intrusion tubes do in a chassis. Part of what we wanted to stress on with this thing is also having it like look legit with the cab off, and taking that vision along the, you know, along for the ride with the original intention here, and making sure that the end result is going to be something where when the cab's not on there, this still looks like a special vehicle, and it still has like a unique look to it, where it's not just a typical like, that's kind of ugly, because it's so geometric based on the constraints of the cab. And I think we've accomplished that. I think this gives a pretty good understanding of where we're going and what we're going for with this thing. I don't want to sabotage the door opening any more than that. I think that we have enough structure into our areas where this thing makes sense for maximum safety, high-speed crashes, you know, stuff over 100. So obviously that stuff sucks no matter what when it happens, but it's better to just build the cage right and, you know, inspire safety and inspire confidence when you're driving than have something where you're always thinking about that in the back of your head, or the time comes when something bad happens and people are getting hurt, especially the people that aren't driving. So we're in a good spot. You can kind of get a grasp on what we're doing structurally with the tube layout. We do need to have the shock mounts in there, but everything's starting to have a home. This thing will fill up. It is a big cab, but once we put 4 seats in here, it is going to fill up. Something to talk about next would be how we are going to attach the cab to the chassis. So part of the thing I wanted to explain with tying in the cab, I mean, if this is a tube that's just in the chassis, say that's a miter tube or it's got other stuff going to it, and your cab is going on the outside of this, you know, that's the backside of it, and this is your interior chassis tube. What we can do is figure out there's a lot of vertical surfaces of the cab, and if we run a plate out to it, and hopefully this makes sense, and I'm just going to darken up where the cab is. So we can run a plate that's welded to our tube here. This is our tube, and there's a plate with a break in it, and we stagger holes in it just like you would you know, any kind of rivet or mating surface on an aircraft, and you stagger those holes. And this is all chrome moly plate that's broke, maybe like 090, or I don't think it needs to be 1/8, but maybe 90. And then you just have proper holes where you can get to with a drill and a rivet gun, and then your factory sheet metal that's back here, which is like the inside of your cab, that can just be your mating surface. And boom, you drill in, and then you can cleco a couple, you drill them all, and then rivet all stainless rivets, and you do a series of these everywhere in there. And what that looks like from the side profile, if this is your tube, say this is the part of your chassis here, and this is your cab, this is like the, you know, the side view. So this is the thickness of your cab, and this is your interior sheet metal on that. Again, you have that plate come out, and it's broke at a 90 or whatever angle it needs to be. You could even build it on tangent. You weld that portion there, and then boom, your rivets go in here, right into the cab. And what that does is that just gives you a surface that's on there that's completely removable, where you can slide another cab on, and you're not doing extensive work to the actual OEM cab. You're just banking on your chassis being set up to land that same style cab. So we'll go look at that on the truck. Since we're on the path here to Bluetoothness, this is our plate. So say there was a tube here. This is all flat surface. This is stuff we didn't have to modify. All we did was just cut out some of the lower portions, but this is just OEM surface. So once we have our tube established in here, this guy can go right in here, and it can register right to the tube. We can trim it, weld it all, and that can span this whole entire portion of the A-pillar section. And we can have rivets set up, holes all staggered, you know, where it will go into this thing, and they will be staggered, like I said, and just enough where you can drill them and get a rivet gun in, and that'll live on the chassis. So that can be kind of tuned up, and that's one tie-in just like that. We can apply that to all the main portions, like the A-pillar portion, the B-pillar portion, the back wall for sure, and definitely the rockers. And that's going to give us a huge amount of surface area that we're grabbing with the chassis, where this is a welded plate into there. So boom, and then, you know, say again, you wanna replace this thing. It has a bad roll and you just need to get a cab. We know where to cut the cab. It's not like any layout or rocket science. We're just literally cutting it flush to this surface. And then boom, we just slip that thing on, and this stuff's already welded onto the chassis. So we just drill, these act as pilot holes. And you just drill right into the cab, the diameter you need for the rivet, 3/16, and then boom, you rivet that thing back on and it's on. Rigid, structural, done. I think we'll do the same thing for some of the A-pillar portions, but just in a little more tastely of a fashion where it's not gonna be ugly. There's a way to do rivets where they work like aviation and aircraft style, and there's a way to do them where you go, dude, why'd you rivet that? So finding that higher road and doing that is the only way we can do this here. So we talked about it before as far as construction on the vehicles in here, running nut plates instead of nut certs. I was raised on using these things for a long time, and they're almost like a temporary thing, because what you're doing with a nut cert, you're drilling a hole that's larger than the diameter of the bolt, and then you're grabbing it and you're crunching all these splined areas to grab into the material. But no matter what, if you're drilling that hole, you're just drilling into a circle, and then you're getting splined areas to grab some of the surface, but it's only as good as that grip. And the moment this thing sees a counter thread or sees a bolt that's got upset threads in it that needs to come out, or anything of that variation, this thing just starts to turn in there. And it is heinous to get these out, especially if it's in a nice area or you can't get it from the backside. Trash, no more. So we do not use these anymore. What we started to use is nut plate. So, you know, this is like a prefab guy, and we've incorporated them into just building. You know, we can build our own and just rivet them the same way accordingly with like an aircraft rivet, just a flush. That is a steel serviceable item. It's got a good coating on there. It doesn't rust. And that thing can be, you know, if it needs to come in, come out, it can. You're not welding a nut to the back of a plate or anything. You're using this thing, and it kind of allows a little movement. There's also floating nut plates which are even better than this, which we'll use those in the right areas. With this, we just want to do a different exercise, and I don't take it as a challenge, but it's nice to mix things up and do things different from the norm. And I guess I've always done that with certain things with thought process, but you know, a couple months ago we messed around with titanium and aluminum and steel. Really started looking into what dissipates the heat the best for like applications like this, with like panels and stuff that's close to your feet with exhaust and all that. And I learned a lot more than I thought, and definitely had some stuff backwards with that, especially with titanium. But you know, using aluminum in some of this, and like whether we're using maybe 90 thou or something even thinner than that in some areas, I think that's where we're going to get wins. And like this trick tab style thing, which is just a double broke thing that kind of lands your tab on tangent. We'll be using a lot of these through here, and instead of just like, you know, making a triangle to fit one portion of the chassis and then welding that in, I think we can do longer runs as long as there's no gaps where they're, you know, kind of flopping around into there. We'll build bigger, like expansive areas that can come out as chunks, as long as the chassis will let them come out, and really experiment with that. And you know, we can even run these things like 6 inches on center, so it's a tight seal still. Put some kind of sealer behind there, and we're not going for like full air conditioned, windowed, sealed cab here, but we'll get it good where it's not like visible, you know, holes where, what the hell, you guys didn't finish that? We'll make sure everything's completely tight like that. If this thing needs to have interior later and wants to get carpeted and headlined, then I will build this so it will fit that spec. And you might just need to use like just something for backup, maybe like a RTV or some kind of silicone or just some kind of body seal in between the joints, just to make sure they're 100%. So look forward to this. Look forward to making the runs, kind of doing things differently, and always being mindful. Remember, original intentions equal end results. So being mindful that this cab can come off and it can be serviced and another one can go back on. So I think there's like a real win you can get in streamlining a lot of this, instead of, like we talked about, just doing like segregated parts and portions, and really run like a bigger dynamic shape where it's drawn into this cab, and tying the chassis in where it doesn't look as such a separated piece. And you know, if we have something big here and it needs to have like a smaller access panel. It needs to have like ventilation, proper ventilation where that goes. Incorporate all that into like a maximized big panel with like a beautiful shape changes. You don't have to necessarily land to every tube. This can streamline over to where it needs to be. And as long as your like standoffs and your spring plates are keeping the same plane through everything, you'll still get a really good shape, and you'll get, you know, like I said, increased functionality of the panel. These are PRP Alphas, composite seat, shell seat, missing the bottom foam, but you can see even how this fits into a little nook in here. It's probably gonna need that. Where the shocks are gonna be, boom, everything starts to really have a home. Everything kind of goes back to that thing I say where each component has its home and it's one place it goes. And that it always seems to be like that with these things, where you can't just freestyle mount where stuff goes. And the more you start to think about like where your chassis is and what you're doing, and you're careful about that stuff, the better things fit in the long run. And the more parts you have to fit into these things when you start, the better it is, because then you're not just, you know, free balling, or you think something's gonna go, well, that thing's about 30 inch, and don't do that. There's room for error everywhere like that. So, you know, things to think about with this stuff. These are rears, they're gonna be the same as the front. There's a lot of room in the cab, so, you know, it does start to get tight really quick. Even like when I do this, you know, we gotta think about how far that tube is, this rear window tube, you know, that thing needs to go back as far as it can right off the bat, because already we're starting to dive into here. So careful consideration with everything. Again, true four-seater, original intentions equal end results. You know, keeping this stuff in mind throughout the whole build, and cycling 4 seats in here. Obviously, we're gonna have a different wrap on these seats, and we have 2 more coming. But figuring out where the harnesses are gonna go, you know, figuring out the seat tabs, all that stuff. You don't wanna start sheet metaling stuff until you know, like, I can already see part of this seat is dipping into the structure here, where we can't just run a flat plane somewhere, because we have to be considerate of the seats. So I think this is probably gonna be part of the next update, is having all these seats in here and seeing a clean layout of where the stuff goes. With that being said, we also need to figure out where we're gonna put foot controls and steering column for the driver, because that stuff has to be rerouted as well. So logistically on this thing, 4 seats, classic scenario again. This thing is just real roughed into here. Obviously need to adjust like angles. I mean, it's probably centered as far as left and right where it needs to be. But just looking at it, looking at the rear seats versus the front, that's gonna have to be something to consider. That's why these things are always so hard to package 4 seats into. So I'm gonna still shoot for that. It's just gonna require some creativity down there. We tried to do it with James's Frontier. We got it where, you know, small children could fit back there, but definitely no dudes. Any full-size dudes can. So this thing's just chilling too. I mean, this thing's obviously gonna have to go inches higher and inboard inches, but you know, it's just a good proof of concept. And then kind of being mindful, put the headers back in and really figure out like cone of vision. And when I say cone of vision, it's just kind of imagining like your eyesight and what you're able to see out the windshield, and, you know, over the front overhang of the hood and everything, and being mindful of that and trying to maximize that. The farther back you sit in the car, you know, these things have like notoriously long overhangs and nose pieces on them. So the farther back you sit, the less you see initially, or essentially, well, the farther back you sit, the less you see. So getting this thing up to where it's still safe and you're not going to make contact with the helmet or anything is primo. I'd rather sit higher than lower, and getting this thing inboard makes sense too, but we just got to figure out the, you know, the controls and kind of the X and Y of the seating, and play both of these at the same time. Also, the sheet metal down there, same thing with our removable panels. And what we're going to do, we really have to just be very conscientious about space and packaging, and not just start throwing big shapes in there just to keep it clean. It needs to be built functionally to house what we want to do for the packaging and constraints inside the car. This should get you guys a pretty good concept and understanding of what we're going to be constructing for this next update. The update before this, we covered what was done physically. This update is our conceptual Bluetooth, use your imagination, and kind of the inner workings of this next phase. So what you can expect to see definitely for this next one is all the tube construction finalized, definitely body mounted, maybe some sort of mock shock mount just so we have the packaging established and have the seats established in here. I always like to say that the first 80% of a build takes 20% of the time and the last 20% takes 80% of the time. It's always the details that take longest. The cages go quick on stuff like this. They always, you know, seeing big like updates and results like, oh my gosh, you guys got a lot done, blah, blah, look at the tube work and this and that. And yes, it was a lot of work and it's definitely big progress, but really it starts to look slow once you start doing all the little detail work because you just don't notice all the things that take so much time. So I hope you guys enjoyed this. Feel free to leave comments, leave questions, share the page, like, subscribe. Have a good Monday. Bye.